What's that B? Silent B. For real B? Lou, you don't know B? What's that B? I don't remember it B. Don't know. Is that the one with addition? No B. That's arithmetic sequence. Arithmetic sequence is when we talk about having a sequence with a common difference. While in geometric sequence, we can have the next terms or the following terms by having a common ratio. Multiply the first term to the second term by a common ratio and so on. That's geometric sequence. Let's move B. I just answered one last week. You don't remember? Classmates, in this example number 1, this is all about geometric sequence. Geometric sequence is a sequence which is or having a common ratio. We can get the following terms by multiplying the first term to a common ratio. Okay, so this formula is the formula that we are going to use in geometric sequence, wherein a sub n is equal to a sub 1 multiplied by r raised to n minus 1, whereas r is not equal to 0. A sub n is our nth term. So a sub 1 is our first term. R is the common ratio. Then n is the number of terms. So using this formula, we are asked to find out the 13th term. Okay, so let's use the formula. But first, we need to find out the given. So what is our a sub 1? What is our common ratio? So a sub 1, of course, this will be 5. The common ratio, you can get the common ratio by dividing second term to the first term, third term to second term. Okay, so 10 divided by 5 is 2, 20 divided by 10 is 2. So we can say that we have a common ratio of 2. Okay, so let's proceed with substitution. So a sub n is equal to a sub 1 multiplied by r raised to n minus 1. So we are looking for the 13th term. So a sub 13 is equal to a sub 1, which is 5. So 5 multiplied by common ratio is 2. 2 raised to n. What is our n? Number of terms, we have 13. So 13 minus 1 is 12. Okay. Then a sub 13 is equal to 5 multiplied by 2 raised to 12 is, using common, 4,096. Okay. Then multiply. 5 multiplied by 4,096 is 20,480. So that is our a sub 13 or the 30th term of this equation. Gets B? Oh yeah, B, I remembered. I also remembered when B. Berna answered about geometric series.
Hello classmates! This example is about geometric series. The geometric series is the sum of geometric sequence. In this example, we need to find the sum of the first 8 terms of the geometric sequence, where 4 is the first term and 108 is the fourth term. So, as we can see, our first term is 4, our fourth term is 108, and our n is 8. We need to find the common ratio. How can we do that? We will use the given terms, especially the fourth term. So, the general term for geometric sequence is an is equal to a sub 1 r raised to n minus 1. So we will substitute it. So a sub 4 is equal to a sub 1. We don't have any common ratio, so we will leave it as r. Raised to n is 4 minus 1. So a sub 4 is equal to a sub 1 r 3. Now we will substitute the given information. So our fourth term is 108. Our first term is 4 r cubed. So, divide both sides by 4 to cancel it out. So, r cube is equal to 27. Then, we need to cancel this. R is equal to 3. Now, we get our common ratio, which is 3. We will use the same process to get the 8th term. So, a sub 8 is equal to a sub 1 r raised to 8 minus 1. So, a sub 8 is equal to a sub 1 r 7. R raised to 7. Next, a sub 8 is equal to, our first term is 4. Common ratio is 3 raised to 7. So, a sub 8 is equal to 4 multiplied to 3 to the 7th power, which is 2,187. So, our a sub 8 is equal to 4 times 2,187 is 8,748. Now, we are going to find the sum of the first 8 terms. Using this formula, S of n is equal to a sub 1 multiplied to 1 minus r raised to n over 1 minus r, where r is not equal to 1. So, we will substitute it. So, S of 8 is equal to, our first term is 4 multiplied to 1 minus r is 3. Then our n is 8 over 1 minus r 3. This is equal to 4 1 minus 3 to the power of 8 is 6,561 over negative 2. This is equal to 4 multiplied to 1 minus 6,561 is negative 6,560 over negative 2. So, using your calculator, our S of 8 is equal to 13,120.
Alright, last, pass your assignments.
Ano to be?
Alright, good morning class. So before we proceed to our topic for today, let us have a short recap from our previous lessons. So we're done discussing geometric sequence and geometric series. As we all know, geometric sequence is different from arithmetic sequence. Arithmetic is focusing on adding a common difference, while in geometric sequence, we are multiplying a common ratio to each term. Now, we can use this formula for geometric sequence. A sub n is equal to a sub 1 times r raised to n minus 1, where r should never be equal to 0. Then in geometric series, we can use this formula. A sub n is equal to a sub 1 multiplied to the quantity of 1 minus r raised to n, all over 1 minus r, where r should never be equal to 1. Why? Because if r is equal to 1, the denominator will be equal to 0. And S sub n will be undefined. So first thing to do is determine the value of r. If it's equal to 1, just simply answer undefined. But if it's not, proceed to this formula. Alright, for today we're going to apply all these concepts in real-life problems or word problems. So let's say for this example, let's have Barbie. Barbie and her employer agreed that she will be given an annual extra Christmas bonus according to the following scheme. 1 peso on the first year, 2 pesos on the second year, 4 pesos on the third year, 8 pesos on the fourth year, and so on. How much extra bonus will she receive all in all after working for 15 years in the company? Based on the problem, we have this geometric sequence 1, 2, 4, 8, and so on. Now, using this formula, the first thing we do is find the values of a sub 1, r, and n. The value of a sub 1, or the first term, is 1. Now, finding the value of r, we have to find the common ratio by dividing the consecutive terms. 2 divided by 1 is 2. 4 divided by 2 is 2, as well as a divided by 4. Now, we all know that the value of r, or the common ratio, is 2. Since we are asked to find the total amount of extra bonus after 15 years, the value of n is 15. That means we are asked to find the value of the 15th term in this sequence. Alright, now we substitute all the given information to this formula. We are looking for a sub 15. So the first term is 1 multiplied to the common ratio, which is 2 raised to n minus 1. Now, following the GEMDAS rule, we deal with groupings first. This one, we just copy 1 times 2, then 15 minus 1 is 14. 1 times 2 raised to 14 is 16,384. Also 16,384. Now we know that on 15th year, the extra bonus that Barbie will receive is 16,384 pesos. But the question is, how much is the total amount of extra bonus Barbie will receive for 15 years of working? Remember that geometric series is the sum of all the terms of a geometric sequence. So we just simply substitute all the given informations to this formula. So we're looking for S sub 15 since we have 15 terms. So we will start with A sub 1. Then multiply to the quantity of 1 minus r, which is 2, raised to 15, which is the value of n, close bracket. Now all over 1, and the value of r is 2. Notice that our r is not equal to 1. Alright, we simplify. Again, we follow the GEMDAS rule. 1. 2 raised to 15 is 32,768. Next, we deal with this subtraction within the bracket. 1 minus 32,768 is negative 32,767. 1 minus 2 is negative 4. 1 times negative 32,767 is just simply the same. Negative 32,767 over negative 1. We'll get positive 32,767 pesos. That means the total amount of extra bonus Barbie received for 15 years of working is 32,767 pesos. Alright? That's all for today. Goodbye, class.
Bye, sir. Bye, sir. Bye, B.